Okay, so to start Unit 2, we're going to talk about solving one-step equations. So in order to solve one-step equations, we have to understand what the term inverse means. So that's both a multiplicative inverse and an additive inverse. So in this review part, it asks you to circle the multiplicative inverse of 1/2 and to underline the additive inverse of 1/2. So the multiplicative inverse of 1/2 is 2. And the reason that is because 1/2 times 2 equals 1. That's the definition of a multiplicative inverse. The additive inverse of 1/2 is negative 1/2. And the reason that is because 1/2 plus negative 1/2 is 0. Okay? So you can try number 2 if you want to pause the video for a second and try number 2 on your own. You can. Also, I'm going to wait a second, and then I'm going to go through number 2. Number 2 states the multiplicative inverse of negative 3 and the additive inverse of negative 3. The multiplicative inverse of negative 3 is negative 1/3, because negative 3 times negative 1/3 is 1. The additive inverse of negative 3 is positive 3, because negative 3 plus 3 is 0. So the main vocabulary term for today is isolate. So to isolate a variable in an equation means you get the variable with a coefficient of 1 alone on one side of the equation. So x equals 12 is an example of a variable that's isolated. 5x equals 60 is an example of a variable that is not isolated. So for number 3, it's just using that vocabulary in a context. It says choose the correct form of the word isolate to complete each statement. So it says a very ill patient was placed in blank away from other patients. A very sick, very ill patient is placed in what's called isolation. In order to blank a variable, you may need to perform mathematical operations. In order to isolate a variable, you may need to perform mathematical operations. And then finally, a person living on a small island felt isolated from the rest of the world. Okay, so isolate means get something alone by itself. So the equations at the bottom here that have a variable that is isolated, there's only 2. This equation and this equation. The thing I want you to notice is that in both of these equations that aren't isolated, 4 is also on this side, 1 is also on the same side. In the other equation, 3 is on the same side. So that's why those equations are not isolated. Moving ahead, addition and subtraction properties of equality. All these properties say is that if I add the same number to both sides of an equation, it doesn't change the truth value of that equation. So an example to the right here, n minus 7 equals 12. If I add 7 to both sides, that eliminates 7 from the left-hand side, and I do the same thing to the other side to keep the equation balanced. Okay. Same happens for subtraction. If I subtract c from the same side, from both sides of the equation, it does not change the value of the equation. It doesn't change the truth value of the equation. So in this example, n plus 8 equals 9, I can subtract 8 from both sides. I can subtract 8 from both sides to eliminate 8, and that keeps the equation balanced. So we're going to talk through the solutions to some of these equations in a few problems. So using subtraction first, it says, what is the solution of y plus 2 equals negative 6? The equation y plus 2 equals negative 6 shows addition on the left-hand side. So the inverse of addition is subtraction, meaning we are going to subtract 2 from both sides of the equation. The reason we subtract 2 from both sides of the equation, it eliminates 2 from this side. That isolates y, meaning y is now negative 8. Okay? So we subtract 2. We do the inverse operation of what's happening on the variable side of the equation. So in the next step, it says check your answer by substituting. If I substitute negative 8 into the original equation, I take negative 8 plus 2 equals negative 6. That is true because negative 6 equals negative 6. So pretty straightforward. Do the opposite operation to isolate the variable. Moving ahead, we do the other two operations we've learned, multiplication and division. If I multiply both sides by the same number, that preserves equality. That keeps the equation balanced. So in this equation to the right, x over 5 equals 10. That's x divided by 5. I would do the inverse of divide. I would multiply both sides by 5. In another case, I can divide both sides by the same number. That keeps the equation balanced. So in the equation 6x equals 30, I can divide both sides by 6 to keep that equation balanced, to preserve the equality of it. So moving ahead to problem 3 and problem 4, we're going to solve equations using division and multiplication. So in this equation, 10 equals 15x. I'm going to talk through the steps of solving this. So you rewrite the original equation. Okay? And I'm noticing that on the variable side, it's 15 times x. So I do the inverse of multiply. I divide both sides by 15. So divide each side by 15. My answer is a fraction, 10 over 15. I'm going to simplify 10 over 15. And that's because I can divide both 10 and 15 by 5. So that's why that becomes 2/3. My variable is isolated. That is my solution. I can check my solution by substituting 2/3 back in for x, and that results in 10 equals 10. So my solution held up. My solution kept the equation true. In example 4, solving an equation using multiplication, it asks what is the solution of r, or 19 equals r divided by 3. We're going to underline the correct word or number to complete each of these sentences for number 12. So to isolate the variable, we should do the inverse of division. That means we multiply both sides of the equation by the same number. And we're going to multiply both sides by 3 because it is r divided by 3. To isolate r, we need to eliminate 3. To eliminate 3, we need to multiply both sides by 3. So in this equation, I'm going to write it to the side, r divided by 3. I multiply both sides by 3. 3 gets eliminated. R ends up being 19 times 3, which is 57, which is my solution. So the final example, or the second to last example, is solving using reciprocals. So to solve this equation, we have to think about 3/4 times x. We are going to use reciprocals, the reciprocal of 3/4. So we're going to multiply, and I know that seems a little odd because it's 3/4 times x, but we're going to multiply both sides by the reciprocal of 3/4. And the reciprocal of 3/4 is really 4/3, okay? So I'm going to go through the steps in this little blank down here. 12 equals 3/4 times x. To solve this, I'm going to multiply both sides by the reciprocal, 4/3. And I have to do the same thing to both sides. So what happens here, 3/4 times 4/3 equals 1. So this just becomes x. And then 12 times 4/3 is 16. So 16 is x. So if I'm checking this, I substitute 16, my solution, back in, and I determine that 3/4 times 16 is 12, so that solution holds up. So it pays to be able to check your solutions once you're finished solving an equation. And I've got one more example, using a one-step equation as a model. So in this equation, it's going to list out a word problem. We're going to read through it, and we're going to set up a variable, or set up an equation and define a variable. So it says an online DVD rental company offers gift certificates that you can use to purchase rental plans. You have a gift certificate for $30. The plan you select costs $5 per month. How many months can you purchase with the gift certificate? So the first thing to do is relate what's happening, okay? Usually the first thing I do is I define a variable in these problems. The variable is what we are looking for, what we are trying to solve for. It says how many months at the end of this problem. So I'm going to let M stand in for months as my variable. And the cost per month times the number of months tells me the amount of the gift certificate. So my equation is going to be $5 a month times M months is $30, okay? Because if the plan I have costs $5 a month, 1 month costs $5, 2 months costs 10, 3 months costs 15. So it's 5 times M is my expression on that side. So my equation is really 5M equals 30. So if you think about it, it's 5 times M equals 30. I'm going to do the inverse of multiplication, which is division. So I'm going to divide both sides by 5. 5 gets eliminated on that side. So the number of months is 6. This gift card will be good for 6 months based on the plan I chose. Okay? So you're not going to do the lesson check. You're going to move on to the practice, and then you're going to work through the checkpoint once you are done with the practice.